Welcome folks to my channel. I'm doing trigonometry, the general solution. Now, I'm going to be applying the general solution in two types of problems. One, where we are given an identity. Two, where we are given a trigonometric equation. Now, if you look at this identity, you will see that it has fractions. Now, if we are having fractions, it means that not all values of the angles will be correct to substitute for this particular identity, meaning the identity will be true for some values of A. Now, look at the first question. For which value or values of A is this identity undefined? Now, if you look at this identity, for it to be undefined, we must have a fraction where the denominator is 0. Folks, remember this in an identity is said to be equals to that. Now, when they say to me, for which values of A is this identity undefined, I take the simplified side and take the denominator because it would be undefined if cos of A plus sine of A is equals to 0. That is very important. Next thing, I'm going to solve for A. Solving for A, it is cos A, I take sine A to that side, it becomes minus sine of A. Even if you can take cos of A to that side, it is not a problem. Now, for us in South Africa, remember, we only accept 3 trigonometric functions, that is sine, cos, and tan. Now, if you look at this, I need to have one of the 3 which is acceptable when I simplify this. That is why in both sides I'm going to divide by cos of A. When I do that, this side I get a 1, that side I get a minus tan A, which is equals to 1. But now, because of that negative there, I divide both sides by a negative sign. Now, my equation is tan A, which is equals to minus 1. Now, I want the values of A for which this identity is undefined. I'm going to solve this using the general solution. That is, A is equals to arc tan minus 1 plus k multiplied by 180 degrees, where k is an element of integers. That means if A is equals to minus 45 degrees plus k times 180 degrees, this would be undefined. Remember now, all the values that you will be getting here when you substitute k by the integers will mean that this particular identity is not defined. We have answered this question. Moving on, it says now prove the identity. Now, for which this would be undefined, would be defined, sorry, not undefined, defined. Now, when I prove, I take the side that can be simplified the most. In this case, I'm looking at the left-hand side. My left-hand side is 1 minus sine A divided by cos A. Remember, the quotient identity for tan A is sine A divided by cos A. I multiply this by cos of A divided by sine 2A. Sorry, cos 2A, not sine 2A. Cos 2A. Now, from here, I'm going to simplify first this bracket. I can see that I am adding fractions with the denominators that are not the same. I'm going to take the LCM, and the LCM in this case is going to be the product of the denominators. That is cos A times 1 there. It would be cos A. Now, I divide all the denominators by this and multiply the quotient by the numerators. Cos A divided by 1 is cos A. Cos A times 1 is cos A. Again, I bring down the minus sign. Cos of A divided by cos of A is 1. 1 times sine A is sine of A. Now, this is multiplied by cos of A divided by folks, be careful here. Be careful here. You see that? That is a double angle identity. And remember, cos 2A, let's put it there, cos 2A is actually equals to 3 expressions. That is cos squared A minus sine squared A. It is the first one. The second one is 2 cos squared A minus 1. The third one is 1 minus 2 sine squared A. What is the meaning of that? It means that if I see cos 2A, I can write it in terms of cos and sine. If I see cos 2A, I can write it in terms of cos. Or if I see that, I can write it in terms of sine. Now, that would depend on what you want. Now, what do we want? We want cos A plus sine A, meaning that we should write cos 2A in terms of the two things that we want from this expression. That is why I'm going to write it as cos squared A minus sine squared A. Folks, I hope that you understand this. I repeat again, cos 2A can be expressed in 3 different ways, but the one that you choose will depend on what you are looking for. Here, I'm looking for cos and sine. That is why I'm going to express cos 2A as cos and sine, as I did there. Now, next one, because I'm multiplying the two, this will cancel that. Now, from there, I'll be left with, sorry about that, cos A minus sine of A divided by, now, look at this. Let's write this one there, 1.2. Look at this. I have the difference of 2 squares. That means I can factorize that denominator into, let's open this up to there, cos A sine A, sine A, because it is the difference of two squares. One is minus, one is plus. Now, from this, I can cancel the same. Therefore, we shall be left with 1 divided by cos A plus sine A. Then we conclude that the left-hand side is equals to the right-hand side. We have proved the identity. We have proved that this is actually equals to 1 divided by cos A plus sine A. We are moving on now. Remember, what I want to stress here was the general solution. Moving on to the next one, I think I should remove this one now because we are done with it, so that we get a little bit of space here. Moving to the next one, which is 1.2. In 1.2, they say to us, determine the general solution of this equation. 6 sine x multiplied by cos x plus 3 cos of x minus 4 sine squared x. Going to remove that. Minus 2 sine x, which is said to be equals to 0. Now, folks, remember the general solution is given in terms of sine, cos, and tan. The conditions of the general solution are given in terms of sine. If it is not sine, it will be cos. If it is not cos, it will be tan. Now, you look at this one here. We've got all those trigonometric functions given there. It's a polynomial of 1, 2, 3, 4 terms. And we should write it in a standard form in such a way that it is a trigonometric equation that has got one function, which is said to be equals to a ratio. Now, one function equals to a ratio, I mean either sine theta is equals to A, or cos theta is equals to A, or tan theta is equals to A. This whole thing must be written in terms of those particular trigonometric functions. How do you do that? Remember, you have done factorization. You need to factorize this. You look at it, 1. It is not a quadratic trinomial. 2. We don't have like terms here. Now, how do we factorize that? By grouping. If you look at this particular equation, if I can take these two terms, there is a common factor, and the common factor, the highest common factor, remember that the highest common factor is 3 cos x. That means I must remove 3 cos of x, and I'm left with 2 sine x plus a 1. Now, what you need to know here is, when you do this in that one, you should get exactly the same bracket. Let's try that. The highest common factor of minus 2 and minus 4 is minus 2. Then I've got sine squared x and sine x. The highest common factor is sine x. Then I'm left with 2 sine x plus a 1, which is equal to 0. Do you see what I was talking about now? The bracket is the same. Now, what does this mean? This is from distributive property of mathematics. It means I can group these two. That is 3 cos x minus 3 cos x there minus 2 sine of x, close bracket and open bracket that side, which is, because of those two, is multiplied by 2 sine x plus a 1. That is equals to 0. Now, I have factorized this there, and the factors are those two. Because I'm multiplying this and it is equals to 0, it means one of them must be equals to 0. Now, I don't know which one, that is why I'm going to say 3 cos x minus 2 sine x is equals to 0. If it is not this one, or 2 sine x plus 1 is equals to 0, it should be that one. I solve for x. I'm going to take this into that side, or I take this one into that side. It becomes 2 sine of x, which is equals to 3 cos x, or it is 2 sine x, which is equals to minus 1. Remember, what am I trying to do here? I'm trying to make sure that this is written in a standard form. Now, South Africa again, you need to have sine, cos, or tangent. That is why I'm going to divide both sides by cos x and 2. That is going to give us tan x. I'm dividing sine x by cos x, I get tan x. I divide 3 by 2, I get 3 divided by 2. I divide by 2 there. Sine x is equals to minus a half. Now, look at this beautiful thing. This is there, and this is there. Now, I can write the general solutions for these two equations happily so. I'm starting with this one. The general solution of tangent says, if tan theta is equals to a, where a is an element of real numbers, therefore the angle will be arc tan theta of the ratio plus k multiplied by the period. Remember, it is periodical. Period of that, where k is an element of integers. Now, we need to take our calculators. We make sure that the calculator is in degrees, and you push shift tan 3 divided by 2, and when you do that, you get 56,31 degrees plus k multiplied by 180. Now, you have written the general solution for this one. Now I'm coming to that one. I'm going to put an or in red, which is this or there. Now, Remember the condition. I want to remind you of the condition. The condition says if sine theta is equals to A and A is between -1 and 1, then A is equals to arc sine theta plus K times 360, where K is an element of integers. Now I'm doing this one because this is between -1 and 1. It will be X is equals to arc sine of -½ plus K times 360 degrees, where K is an element of integers. Now, we simplify this with our calculators. It would give us -30 degrees plus K times 360 degrees. Remember, this one has two solutions. It says again, theta is equals to 180 degrees minus arc sine of the angle. Now, in this case, it would be X is equals to 180 minus 30, which is going to be 210 degrees plus K times 360, where K is an element of integers. We have answered this beautiful question, folks. Remember, you need to know your stuff here in trigonometry. Go to our channel, like the channel, subscribe, leave a comment which is positive and encouraging. Encourage your friends to also subscribe. Don't succeed alone, succeed with the others. Peace.